Hello everyone, welcome to Sai Niketan online classes. In this class, let us discuss the next application of the derivative, that is increasing function and decreasing function. So, in increasing function, how we have to use the derivative to say the given function is increasing, and also for a given function, how we are say that the given function is decreasing by using the derivative, right? So before using the derivative to say the given function is increasing and decreasing, first let us know what is mean by increasing function and what is mean by decreasing function. So in increasing function, we will say the given function is increasing and also it is a strictly increasing, and the given function is decreasing and the given function is strictly decreasing. For that, first we will see the basic definition to understand what is mean by increasing and decreasing function. So for this I will write the definition. So definition, let y equal to f of x be a function defined on I means it is an interval, then here we will write, then first one is, so as x increases, then f of x also increases, is called increasing function, right? So is called increasing function, okay, right? So later we will see the strictly increasing function. So second one is, as x increases, then f of x decreases, is called decreasing function, So this is the basic definition to know what is mean by increasing function and what is mean by decreasing function. So first we will see what is mean by increasing function. So as the value of x is increases, then f of x is also increases. If you want to increase the value of x, then the functional value is also increases. Such a functions are called increasing functions, right? Similarly, as x increases, then f of x is decreases. If you want to increase the value of x for the function, then f of x is decreases, then such a functions are called decreasing function. So for this definition, to understand the increasing function and decreasing function, let us see the graph of the function. By seeing the graph of the function, then it is very easy to judge the given function is increasing or decreasing. So here I will write some of the examples, some of the graphs to know the meaning of these definitions, okay, right? So here I will take the graph like this. So x-axis, here y-axis, and here it is origin. Here I will take some of the graphs to know the definition of the increasing function and decreasing function, okay, right? So here I will take y, here I will take one more graph, so like this, here x and here it is y, okay, right? So in this graph, first I will take the graph like this. So here it is a linear function, and after that it is a constant, and here it is again it is a linear function, okay, right? So here I will call this as y is equal to f of x, okay, right? Next, here I will take one more graph. So here I will take, so this is the graph of y is equal to f of x, okay, right? Now I will take the graph like this. So here it is like this, we will take, okay, right. Again here it is y is equal to f of x, okay, right. So here I will take like this. So here the graph like this, okay. So here y is equal to f of x, okay. So here I have written some of the graphs. So from the graph we will say that the given function is increasing or decreasing. So here what I have written, as x increases then f of x is also increases, that is called increasing function, and as x increases then f of x is decreases, okay. So here you should observe, so this is the graph and here it is a linear function from this to this. So if you want to increase the value of x, then the graph is goes upward, and here again if you want to increase the value of x, then the graph is constant, and again here if you want to increase the value of x, again it goes the upwards. So it means that as x increases, f of x is also increases along the y-axis. Here also, here these are the values of x. If you want to increase the value of x, then f of x is also increases. Hence these two graphs are example for increasing functions. And again here we will call this as only increasing function, and here we will call this function as increasing, but we will say this is a strictly increasing, okay. Now let us discuss about increasing and strictly increasing later. So again here you should observe, here if you want to increase the value of x, if you want to increase the value of x, then the graph of this function gives the linear function, again it to take the constant, and again here it is a linear function, and here it is a decreasing. It means that if you want to increase the value of x, then the graph of this function is decreases. It means that if you want to increase the value of x, f of x is decreases. Here also if you want to increase the value of x, then f of x is decreases. Hence these are decreasing function, and here it is only decreasing or it is a non-increasing function, and here we will call this as a strictly decreasing function, okay. So this is about the graph. So from the graph or from this definition we are explaining this graph, okay. Here also once again we will see the definition. As x increases, f of x is increases, that is called increasing. As x increases, then f of x is decreases. So again for this graph we will give the mathematical definitions, how x increases and how f of x is increases, how x increases, f of x is decreases. So let us see those. So here I will take, so here I will take this as a x1, this as a x1, and here I will take this as a x2. Corresponding x1 and x2 you have the functional values. So here we will call this as f of x1, and here we will call this as a f of x2, okay, right. So here x1 is increases, then f of x1 and f of x2 are same. If you take one more point here, so here if you want to take another point x3, then what is the functional value that gives the f of x3? So here f of x1 means here you are getting f of x1, right. So this distance is f of x1. Here also, here it is a f of x2. For if you take for this point, so here we will call this as a f of x3. So here you see that as x increases, f of x for this function, f of x is increases. Also at the same time the functional value at x1 is the same as the functional value at x2. So it means that as x1 less than x2, x1 less than x2, this implies f of x1 either which is less than or equal to f of x2. So here x1 is less than x2, but the functional value here it is same. If you take one more point, then that may be less than. So therefore x1 less than x2, this implies f of x1 is less than or equal to f of x2, then such a functions are called increasing functions. Such a functions are called increasing functions. Okay, so increasing function means you are having the both the sign less than and equal to, so hence they are called increasing. Okay, now here you should observe the graph of this function. Here let us see the some of the points. So here I will call x1 and here I will call this as x2. For x1 you have the corresponding value, this is called f of x1, and for this you have the functional value, that is f of x2. Okay, so here you should observe as x increases f of x is also increases. So here x1 and here it is a f of x1, here x2 again f of x2. So it means that as x increases f of x is also increases. So we will write mathematically like this. So x1 is less than x2, is it right? This x1 is less than x2, then what is the condition? F of x1 is less than f of x2. So clearly as x1 less than x2, f of x1 is also less than f of x2. So this is called a strictly increasing function. So it is called a strictly increasing function. It is called strictly increasing function. So now it is increasing function, it is having both the sign f of x1 less than or f of x2, but here if you take strictly increasing, so here as x1 less than x2, then f of x1 is less than f of x2. So therefore hence it is called strictly increasing. So these are the mathematical definition to understand what is mean by increasing function and strictly increasing function. Okay, right. Now let us go to this function. Before that, first I will take this one. So here I will take this as a x1 and here I will take this as a x2. Okay, so here x1 is there. What is the functional value here you are getting? So here you are getting f of x1, is it right? And here what is the functional value? So this is the f of x2. So here also you should observe as x1 increases, then f of x is decreases. So if you want to increase the value of x, then f of x becomes what? Decreases. So therefore we will write like this. So x1 less than x2, this implies f of x1 more than f of x2, right? So here less than here I have written, but here as compared to f of x1 and f of x2, which one is more? F of x1 is more. So therefore x1 less than x2, this implies f of x1 more than f of x2. So it means that as x increases, f of x is decreases. So hence it is called a strictly decreasing function. Strictly decreasing function. Okay, right. Next we'll go to this graph. So here you should observe here it is a x1 and here you are having x2. What is the functional value here? F of x1. And what is the functional value at x2? Again here we are getting f of x2. And also if you take x3, then x1 is less than x2, is it right? But the functional value at x1 and x2 is the same. So therefore we will write like this, as x1 less than x2, this implies f of x1 more than or equal to f of x2. It means that either it may be equal to or it may be more than x1. So hence it is called a decreasing function. Okay, so this is the mathematical definitions to understand what is mean by increasing and what is mean by strictly increasing, what is mean by decreasing function and what is mean by strictly decreasing function. So here once again here I will write the definitions. Okay, now we will write the mathematical definitions of increasing and decreasing function. So here let y equal to f of x be a function defined on the interval I, then so first one is for all, or we'll write like this, for all x1 less than x2, this implies, sorry, we'll write like this, if x1 less than x2, this implies f of x1 less than or equal to f of x2 for all x1 x2 belongs to the interval I, then f is increasing function, f is a increasing function. Okay, right. Similarly, here we'll take like this, if x1 less than x2, this implies f of x1 less than f of x2 for all x1 comma x2 belongs to I, then f is strictly increasing function. So for this, to take this graph. Okay, right. So similarly, third one is, if x1 less than x2, this implies f of x1 more than f of x2 for all x1 comma x2 belongs to I, then f is decreasing function. Then we will call f is a decreasing function. Similarly, the fourth of x1 less than x2, this implies, sorry, here it is more than or equal to, right, and here we are getting f of x1 more than f of x2 for all x1 comma x2 belongs to the interval I, then f is strictly decreasing function. So these are the mathematical definition to know what is mean by increasing function and what is mean by strictly increasing function, what is mean by decreasing function, and what is mean by strictly decreasing function. So let y equal to f of x be any function, then x1 less than x2, this implies f of x1 is less than or equal to f of x2, then such functions are called increasing functions. x1 less than x2, this implies f of x1 less than f of x2, then that is called strictly increasing function. x1 less than x2, then f of x1 more than or equal to f of x2, that is called decreasing function. x1 less than x2, this implies f of x1 more than f of x2, then such functions are called decreasing function. So these are the basic definitions or mathematical definitions of increasing functions and decreasing function. And also we have one more function, that function is neither increasing nor decreasing function. When we will say the given function is neither increasing nor decreasing function, so for this let us take one more graph of the function. That graph of the function, here I will take the graph of the sine function. Okay, right. Okay, so next, suppose if you take the graph of the function like this, right, here if you take the graph of this function like this, right, so clearly this is the graph of y is equal to f of x is equal to sin x. So this is the graph of the sin x function. So here you should observe, here 0, here pi by 2, here it is pi, here it is 3 pi by 2, and here it is a 2 pi. So here you should observe, from 0 to pi by 2 the given function is increasing. Again from pi by 2 to 3 pi by 2 the given function is decreasing. Again from 3 pi by 2 to 2 pi the given function is increasing. So here the given function in this interval 0 to 2 pi, it is always not increasing and always not decreasing. So such a functions are called neither increasing and nor decreasing functions. So because if you take the total interval from 0 to 2 pi, the given function is increasing and decreasing, again it is increasing. So therefore from 0 to 2 pi this function is not always increasing, not always decreasing. So it means that the sign of the function is not the same. So hence it is called neither increasing function nor decreasing function. But here if you take from 0 to pi by 2, the interval x belongs to 0 to pi by 2, if you take in this interval, then the given function is increasing. So in that case we will say that from 0 to pi by 2, open interval 0 to pi by 2, if you take only in this interval, then we will say that the given function is increasing function. From pi by 2 to 3 pi by 2 if you take, then the given function is decreasing, right? And again from 3 pi by 2 to 2 pi, again it is increasing. It means that if you take only in this interval, then we will say that the given function is increasing. From 0 to, so from pi by 2 to 3 pi by 2, if you take only this interval, then we will say that the given function is decreasing. Again if you take only in this interval, again the given function is increasing. But if you take the total interval, in this total interval it is increasing, decreasing, again it is increasing. Hence in the total interval 0 to 2 pi, we will say that the given function is neither increasing nor decreasing. Okay, right. Now this is the mathematical definitions related to increasing function and decreasing function. Now let us see the application of the derivative. By using the derivative, we will say that the given function is increasing and the given function is decreasing. How we will say the given function is increasing and decreasing? By using the derivative, right? Now let us discuss about that one. Before that, let us see the equation of a line in a slope intercept form, right? So if you take y is equal to mx plus c, so what it represents? So clearly it is a linear function with slope m and y intercept is c, right? If you take the graph of this function, so I think you are getting like this. So what it represent? Y equal to mx plus c, right? Right. So here what about m? M is nothing but what? Slope. M is nothing but what? Slope. Slope is also nothing but what? Tan theta, right? So in a differentiation we will write m is equal to dy by dx. We will write slope of a tangent, we will write dy by dx. So that is nothing but what? Tan theta. Okay, right. So m is nothing but slope, slope is nothing but what? Tan theta, or m is nothing but what? Dy by dx, or this is nothing but what? Tan theta. Again dy by dx means we will write like this, f dash of x. F dash of x is also nothing but what? Dy by dx. Okay, right. Now here y equal to mx plus c, so it is a equation of a straight line in slope intercept form. So here I will take the two equations. So to understand how we will say the given function is increasing or decreasing by using the derivative. So here I will take the graph like this. So y is equal to 2x plus 3. Is it right? So if we want to draw the graph of this function, so here what you are getting? So here x, here y. Here I will substitute x equal to 0 with the value of y 3. If you take y equal to 0, then what is the value of this one? That is minus 3 by 2. It means that minus of 1.5. Okay, right. So if we take the graph here, so here I will take 1, here it is 2, here it is minus 1, here it is minus 2. What is the first point? 0 comma 3. So here only will take, this is 3, here I will take 2, and here will 1. Okay, right. So this is the graph of this function. X equal to 0, y equal to 3 means here one point, and y equal to 0 and x equal to minus 1 by 2 means here. So here we are getting this one, right? So what it represents? Y equal to 2x plus 3. Is it right? Okay, right. And here you should observe what is the slope of this line. So slope means m, that is nothing but what? 2. So if you take y is equal to 2x plus 3, then the slope of this line is 2, right? Again here you should observe the slope is positive, here plus 2 is there, then the angle made by this line with the positive direction of x-axis that lies in the first quadrant, right? Or it forms the acute angle. So acute angle means the slope equal to m, that is nothing but what? Tan theta. So theta makes acute angle. Acute angle means it is less than 90. So clearly tan theta is equal to what? Positive. Okay. So tan theta is nothing but what? Dy by dx. So therefore we will write dy by dx is equal to what? Positive. Okay. Dy by dx is also nothing but what? F dash of x equal to positive, right? So therefore f dash of x is positive. It means that the slope of this line, that is a positive. Hence we will say that this is a increasing function, because if you want to increase the value of x, then the value of y is also increases, and y equal to 2x plus 3, it is a linear function having the slope m, that is equal to plus 2. So tan theta is equal to positive. So tan theta is nothing but what? Dy by dx. Dy by dx is nothing but f dash of x. F dash of x is nothing but positive. So here also if you want to increase the value of x, then f of x is also increases. So hence it is a y equal to 2x plus 3, it is a increasing function. So we will say this is a increasing function only when its slope is a positive. So therefore you should remember, increasing function means its slope is always a positive. So positive means we will write like this: f dash of x that is equal to, or f dash of x is more than 0. So here you should remember, the slope of any line that is positive, then we will say that the given function is a increasing function. Okay. Similarly we will take the same line like this: y is equal to minus 2x plus 3. Y equal to minus 2x plus 3. So here if you take the line like this, right? So here it is x, right? What is the value of x? X equal to 0. What is the value of y? 3. Y equal to 0. Then what is the value of x? Suppose if you take y equal to 0, then here you are getting a 3 by 2 means 1.5. So here if we draw the graph of this function, here we are getting 1, 2, 3, and here it is 1.5 means here we are getting like this. So clearly this is y is equal to minus 2x plus 3, right? So this is the angle. So here you see that this line makes an obtuse angle with the positive direction of x-axis, and hence its slope is negative. So therefore m is equal to negative, right? So m is equal to negative means slope is negative. Slope is negative means we will take f dash of x equal to negative. F dash of x is negative means we will write that is less than 0. So from these linear equations, right, or from these linear functions, we will say that if slope is positive, then the given function is increasing. When the slope is negative, then the given function is a decreasing function, right? So this is about linear functions, right? So the same concept we will apply for different types of the graphs as we discussed in previous. Here we will take the same graphs to say the given function is increasing and decreasing. Okay, right. Okay. So now let us see how the derivatives are used to say the given function is increasing and decreasing. So for this here I will take the graph, same graph here will take, here x, it is y, here it is origin, here will take like this, sorry, here will take, okay, okay, this is the graph. Here it is a graph of increasing function, right? So here we'll take like this, okay, this is the graph of strictly increasing function, and here we'll take x, here it is y, here we'll take like this, okay, right. Similarly we'll take like this, x is y, like this, right? So clearly from the graph we will say that as x increases, f of x is increases, hence it is an increasing function. X increases, y, f of x increases, hence it is a strictly increasing. X increases, f of x decreases, hence it is a decreasing function. And here it is x increases, f of x decreases, hence it is called a decreasing function. Now let us see how derivatives are used to say the given function is increasing or decreasing, okay, right. So here I will take for this one, here for this graph is y is equal to f of x, right. So for this graph, if I want to draw a tangent at any point on this curve, suppose if I want to draw a tangent here, so clearly this is a point A, I want to draw a tangent to this curve at this point, so here I am getting the tangent like this, right. Here also if I want to draw one more tangent at this point B, so here I am getting the tangent like this, okay, right. And if I want to draw one more tangent at this point, here I am getting the slope of the tangents, okay. So here you should observe at this point, if I want to draw a tangent to the curve y equal to f of x, so clearly this tangent makes, an angle theta with the positive direction of x axis, and here the theta formed is acute angle trine. So here it is a acute angle. So acute angle means, so clearly this angle theta lies in a first quadrant. So first quadrant means how we will write a slope. Slope, that is nothing but what? Tan theta. So tan theta, it lies in the first quadrant. First quadrant means tan theta is a positive, right? Slope means how we will write? So we will write a dy by dx. Dy by dx is equal to what? Positive. So dy by dx means we will write f dash of x. F dash of x is equal to positive. F dash of x is positive. Positive means we will take like this, f dash of x is more than 0. Right. So therefore you should remember the condition for strictly increasing function. Condition for strictly increasing function. What is the condition for strictly increasing function? So f dash of x is more than 0. F dash of x more than 0. So f dash of x is more than 0, then we will say that the given function is a strictly increasing function, right? So here if you want to draw a tangent for this curve at any point, then that tangent, slope of that tangent makes an acute angle with the positive direction of x axis. So here slope is nothing but what? Tan theta. Tan theta lies in the first quadrant. First quadrant, tan theta is a positive. So tan theta is nothing but what? Dy by dx, that is positive. Dy by dx means f dash of x. F dash of x is positive. F dash of x is positive means more than 0. Positive value means f dash of x should be more than 0, then you are getting the positive value. So therefore you should remember, for strictly increasing function, what is the condition? F dash of x is more than 0. Okay, right. So here also, here this is point A and here it is a point B. Suppose here the line AB, so before that here you should observe it is a linear function. right? So it is in the form of y equal to mx plus c. So here it is a linear, again the function takes the constant value, again here again it is a linear, hence it is linear function, again here it is a increasing. Okay, so you already know that if it is a linear function, if it is a linear function which makes an angle theta with the x-axis, then here tan theta is positive, here slope is positive, here also the slope is positive, and here if you take the slope is 0, because if you want to draw a line, or if this straight line itself represents the slope of the tangent, because at every point if you draw a tangent, those tangent that itself represent a straight line, and here this is a straight line, this is a parallel to x-axis. You already know that any line which is parallel to x-axis means its slope is 0. So here you are getting the slope is 0, and here you are getting the more than 0, here the slope is more than 0, slope is more than 0, slope is equal to 0. By combining all these, so here we are getting the condition for increasing function, that is f dash of x is more than or equal to 0. Because in this case here the functional values are same, it means that it is a constant function, it is a line parallel to x-axis, hence its slope is 0. For this, here it is positive and here it is a positive, hence the positive means slope is more than 0. By combining this, here we are getting f dash of x more than or equal to 0. Or if you want to draw a tangent at any point on this, right, so at any point on this means so clearly the slope is the same as a linear function. This, if you want to draw a tangent at every point on this line, that itself gives the straight line. So hence here it is a positive, here also if you want to draw a tangent at any point on this line, that again gives the straight line only, hence here it is a linear function, slope is positive, slope is positive, slope is equal to 0, hence f dash of x is more than or equal to 0, hence we will say that this function is a increasing function, this function is a increasing function. So increasing function means, so here you are getting f dash of x more than or equal to 0. Here if you take strictly increasing function means, so only f dash of x is more than 0. So here for to say the increasing and decreasing function, you have to take the open interval, because in end points it is not possible to draw the tangent. So hence strictly increasing means here it is more than 0, and increasing function means f dash of x is more than or equal to 0. Okay, right. You should remember these 2 points. Okay, right. Now let us go to the next graph of the functions. So here it is x-axis, here it is a y-axis. So see here, if you want to draw a tangent, so tangent to this curve y equal to f of x. Suppose if I want to draw a tangent at this point, so here you are getting like this, this is one tangent, and here if you want to draw one more tangent at this point, again you are getting like this, right? Here you should observe all these lines, right? So all these lines makes an angle theta, and this theta is obtuse angle. Obtuse angle means clearly it is more than 90. More than 90 means so clearly tan theta lies in the second quadrant. Tan theta lies in the second quadrant means tan theta is negative in the second quadrant. So therefore m is equal to slope. Slope is equal to what? We will write, that is a tan theta. Tan theta is equal to what? Negative. Because tan theta is a negative, because it is obtuse angle, hence clearly theta lies in the second quadrant. Second quadrant means tan theta is negative, so tan theta is nothing but what? Dy by dx. Dy by dx is equal to negative. Dy by dx is nothing but what? F dash of x equal to negative. F dash of x is negative means we will take the values less than 0. So therefore, for strictly decreasing function, what is the condition? The condition for strictly decreasing function is f dash of x less than 0. Here why I have taken f dash of x less than 0? If you want to draw a tangent for any point on this curve, that slope of that tangent makes an obtuse angle. So clearly theta lies in the second quadrant. Theta lies in second quadrant means tan theta is negative. Tan theta is nothing but what? Dy by dx is negative. Dy by dx is nothing but what? F dash of x. F dash of x is negative. F dash of x is negative means less than 0. So f dash of x is less than 0, then we will say that the given function is a strictly decreasing function. Okay, right. So now let us go to this graph. So here we will write this is a decreasing function. So clearly it is a decreasing function. So here you should observe, here it is a linear function. If you want to draw a tangent at any point on this line, so that itself gives the straight line. So clearly here also this theta makes, so clearly this makes an angle, obtuse angle. So clearly obtuse angle means tan theta is negative, so that is nothing but dy by dx is negative. But here if you want to take the function, so here the functional value is constant. Constant means here the slope of the tangent for this line is parallel to x-axis. So clearly the slope of the line is parallel to x-axis means here slope is 0. And if you want to draw tangent for any point on this line, so again they make the angle theta, and that theta means that is obtuse angle. Clearly tan theta lies in the second quadrant. Tan theta lies in second quadrant means slope tan theta is negative in second quadrant. So therefore we will write dy by dx. Dy by dx is equal to what? Negative. Dy by dx is nothing but what? F dash of x is equal to negative. F dash of x is negative means here we will write less than 0, but here the slope is parallel to x-axis, hence we will add less than or equal to. So therefore what is the condition for the given function is strict decreasing function? Therefore f dash of x is less than or equal to 0, right? So if f dash of x less than 0, less than or equal to 0, then we will say that the given function is decreasing function, and the given function is strictly decreasing only when f dash of x is less than 0. So this is about, by using the derivative we will say the given function is increasing and strictly decreasing, and decreasing and strictly decreasing. So it means that if f dash of x more than or equal to 0, then the given function is increasing function. The given function is f dash of x is more than 0, then we will say that given function is strictly increasing function. And for a decreasing function means if f dash of x less than or equal to 0, then we will say that the given function is decreasing function. And if f dash of x only less than 0, then we will say that the given function is a strictly decreasing function. Okay, right. Now let us see some of the graph. Those graphs are said to be neither increasing and nor decreasing function, right? So when we will say that the given functions are neither increasing and nor decreasing function, right? Okay, right. Suppose the graph, the function here I have taken like this x-axis and here it is y-axis. Suppose here if you take the graph of this function, y is equal to f of x, right? So here it is 0 and here it is pi by 2 and here it is pi and here it is 2 pi. Okay, so if you want to draw a tangent tangent to this graph at this point. So here what you are getting, here f dash of x is more than 0, and if you want to draw one more tangent, so again here it is a tan theta is negative, and here also tan theta is negative, here also the tan theta is negative, and here also the tan theta is positive. So it means that here f dash of x more than 0, f dash of x less than 0, f dash of x here less than 0, f dash of x more than 0. So for this function here more than 0, here less than 0 means the sign of this function. So sign of f dash of x is not same. So here it is increasing, here it is decreasing, again here it is decreasing, again here it is increasing. So in this total interval 0 to 2 pi, so the sign of f dash of x is not same. So hence such a functions are called neither increasing functions and nor decreasing function. But if you take from 0 to pi by 2, from 0 to pi by 2, if you take x belongs to the interval 0 to pi by 2, then in this interval we will say that the given function is strictly increasing. If you take the interval pi by 2 to pi, again we will say that the given function is strictly decreasing. But if you take from 0 to 2 pi, then the sign of f dash of x is not same. Here the